Good morning. First of all, I'd like to walk you through the foundation system. These are pods. These are what we call the KOTO K pods. First of all, the pods are laid out on top of a piece of plastic. Plastic sheet is rolled out, and the plastic stops the moisture coming up in times of drought. So as the pods are placed down, and then the reinforcement mesh goes over the top, formwork is put to the outside. So what we've done now is created a network of beams. The beams are running north and south on the floor slab, and the beams are running east and west. These are connected to the outside edge beam. So the outside edge beam is a thickened beam, and this is where we place the first starter bars. So in the starter bars are projecting out of the ground 450. The first panels will come over the top of here, over the starter bars, ready for the next installation. You'll see on the corner here, we have 3 bars in the corner. Okay, so that gives you 3 times racking. And in the case of an opening, if we have 2 bars, that gives us 2 times more racking. So we're up to 5 times racking. Basically, it's a very, very simple floating slab, a raft slab, that will not give you any trouble because of the network of beams floating north and south and east and west connected to your edge beam, your thickened edge beam. So as we place the first panel, most architects have a panel, a window that's 900 high. So in our case you can use any windows, but we particularly like these windows because of the architrave. And another good reason for using this type of window is the installation. Window installed, ready for the next panel to slide in here or slide in here. So this type of opening will always have behind it a reinforcement of a bar. And if we have this section taken out and we have 2 bars, then that gives us the 5 times racking. Now, in this case scenario, the engineer determines which core holes will be filled with concrete. Some will be left open, and these are excellent for your services, computer cables, air conditioning, but the engineer determines which core holes are going to be filled. In this case, the reinforcement comes from your starter bar, through the thickened edge beam, up through the core, and to your bond beam at the top. As you can see over here, this bond beam is a typical example. Reinforcement, cutaway version, and up through the bond beam at the top. So all one has to do is place the steel and pour the concrete. In this application you can see that this is a very wide panel because this comes from our Korean factory. Why is it so wide? Because they have minus 20 degrees. So therefore the insulation factor is far greater. Now if we look at the finishing and we have plaster and paint, this could be considered as our affordable housing. But if we have the same building system and we apply here, we apply a marble, granite or high quality finish, it's our upmarket housing. However, the building system is still the same. Now, I'd like to point out something quite unique here in the way of engineering. Let's just say that our engineer wanted to have, in this section, a thickened vertical beam. So we would immediately take out these 2 pieces here and we would insert the respective steel, and we've now created within 30 seconds a thickened enlarged beam. Once again connecting to the thickened edge beam and up and around to the bond beam at the top. Okay, so now let's assume that we're up to the level and we're going to do a flooring system. Now in this case I'm just going to show you a form. It's not finished or not in its full entirety because this is also a form like our walls are a form that you can pour concrete and steel to the engineer's design to give you that structural element or shear wall function or diaphragm function. The same as a form for our slab systems, the K-pods, are also a form. Okay, so in this case I want you to use your imagination. Imagine we have this form with a fireproof coating. But in here, I embed into here for you a reinforcement steel. A reinforcement steel. And this is your fireproof coating. So for the flooring system, I will mount this here. And as you can see, nothing underneath. It's not important because it already has the stiffness inside. And I can walk across here immediately to lay the next one and the next and the next. So the engineering specifications will tell us what size mesh to use on the floor and the thickness of the concrete and the grade of the concrete. And hence we have a flooring system. But just before we pour the concrete, we will put a temporary prop, just a couple of minor temporary props, in the center of the room to facilitate the weight of the concrete. Now, if I take this form off and I turn it over like this, and I use this type of bracket, then I can have this as my flat roofing system. Typically you may use this in countries like the Arab countries, United countries who like to have flat roofs, or any country with a flat roof. Mind you, we are not limited to just a flat roof. Again, use your imagination. Over here, a fire-rated coating, and here, by changing the back bracket and by bonding on the metal roofing on here, one can have a metal roof or a tile roof. So essentially, what we've covered now is foundation using a form. We've covered a walling system using a form. We've covered a flooring system using a form. And this is how the KOTO building system goes together. You will notice here that these core holes are different. These are designed as such for zone 4 seismic conditions or cyclonic wind conditions of 70 meters per second. So ladies and gentlemen, that gives you a brief overview of how the KOTO system goes together. Thank you very much.